In the last part of today, we're going to use the noisy channel theory to try to gain insight into a long-standing and very empirically interesting and puzzling psycholinguistic phenomenon. You can think of this as an incremental processing phenomenon or as a global processing phenomenon. First, I'm going to give you two versions of a sentence, and I want you to just pay attention to your introspective judgments about which version of it sounds better or more English-like, more acceptable to you. The first version: the apartment that the maid who the cleaning service sent over was well decorated. The second version: the apartment that the maid who the cleaning service sent over cleaned was well decorated. Now, if you're like most people, you probably feel that version 1 sounds better and something sounds wrong with version 2. But actually, if you look closely, you'll find that despite the thumbs up, thumbs down pattern that I'm illustrating here, actually it's sentence 1 that is ungrammatical and sentence 2 is grammatical. And we can see this by coloring in the matching subject-verb pairs in the sentence, and let's just inspect that for a moment in sentence 2. We've seen multiple, these are examples of multiple center-embedded object-extracted relative clauses, and let's just reconstruct who's doing what to who in this sentence. The cleaning service sent over the maid cleaned the apartment, and the apartment was well decorated. That's 2. There's a subject and a verb match at all levels. In sentence 1, on the other hand, if you actually look carefully, there's a verb that's gone missing. The middle verb in sentence 2 has been deleted. And so actually the sentence doesn't make any sense. It doesn't actually convey a complete proposition, where sentence 2 does. Despite that, people generally find 1 more acceptable or feel that is more acceptable than 2. And so that is that we can take this very complex structure and remove that center verb, and somehow that actually makes it sound better. And that's really puzzling, because one would think that the reason that things sound good or bad to a first approximation is that they convey complete meanings that makes them sound good. They don't convey complete meanings that makes them sound bad. There's something missing. But that's actually not the subjective pattern. So this is what's called the structural forgetting effect. That is, that part of the sentence seems to be forgotten by the time you get to the end. And this creates what sometimes we call a grammaticality illusion. That is, that the ungrammatical sentence seems better than grammatical sentence. And this is almost like a more extreme version of some of the phenomena that we saw earlier today and in the last lecture. That is, in those cases, we had a grammatical sentence that was interpreted as if it were of another structure. In this case, we have an ungrammatical sentence that seems more grammatical than the corresponding grammatical sentence. So let's think about this. I want to give you, first of all, the empirical basis. This is something that's been studied. It's a very robust phenomenon. There are many ways that are studying it. Here are 2 example well-known papers on this. So in the Gibson and Thomas paper was the first that really used controlled experimental psycholinguistics methods. An example sentence from their study is given up here. The ancient manuscript that the graduate student who knew card catalogs be confused a great deal was studying the library with missing a page. In the bottom left, we see bar graphs of the acceptability or really easiness to understand judgments that people give. High numbers are hard to understand. And we have each of the 3 verb phrases was either removed or none of them was removed. And we can see those 4 conditions. And the least hard to understand versions are the ones where either nothing was removed or the middle verb phrase was removed. So here we have a case where removing the middle verb phrase on this experiment doesn't reduce easiness to understand. Another version of this was Christensen and McDonald, 2009. They did a slightly different presentation technique. They used word-by-word self-paced reading, which you're familiar with now. And after finishing reading and the sentence, they had participants rate the sentences on what they called goodness, and now high numbers are bad. Examples here are a little different. So these are just individual verbs rather than these verb phrases that Gibson and Thomas used. So for example, the chef who the waiter who the busboy offended appreciated, admired the musicians. And here they only contrasted the intact sentence with the version where the second verb was missing. The word appreciated was removed. Removing that individual second verb reduced the acceptability, or excuse me, it increased the goodness from the subjective point of view of the participants for these sentences. So this is the structural forgetting effect. That's some empirical documentation. There are also other incremental processing demonstrations of this using self-paced reading types. However, to add to the puzzle, the effect is language dependent. And it turns out that if we, for example, translate this into German, German is a little different in a lot of ways. It has case marking. It has obligatory commas in the orthography when you introduce a relative clause. This is basically a word-for-word translation into German, but actually it turns out that German native speakers actually find the latter version, the one that has no verb phrase has gone missing, better than the upper version where there is a verb phrase gone missing. This also turns out to be true in Dutch. So this is actually really an interesting puzzle because it shows that, so intuitively, this has something to do with the fact that these sentences are taxing the memory resources of a comprehender. Obviously, we've stacked this highly center-embedded structure, but it's not the case that there's sort of some static characterization of memory and syntactic structure that will predict the overall difficulty patterns across the languages of the world. We can just take these two languages, which are actually very similar to each other in a lot of respects, English and German, and we can get the opposite patterns between the two. That is that the German speakers prefer not to have the verb phrase go missing, and for the English speakers, we saw in multiple experiments that either it doesn't hurt to have the middle verb phrase go missing, or it actually makes things feel better. So that's very interesting because it suggests that there's some interesting interaction between the overall structure of the language, not just the particular structure involved, but the overall distributional character of the language, and memory resources in some generally characterizable way that are interacting together to give this cross-linguistic variability in processing. Now, there's been an empirical demonstration that, that we can account for this cross-linguistic pattern by showing that, for example, we take simple recurrent neural networks, train them on English versus German. It turns out that, that one gets a higher probability, for example, than two in English, but not in German. But that doesn't really give us a theoretical explanation for why. So it turns out that if you train a recurrent neural network model, it can learn this pattern. But does that actually fall out for some theoretically explicable reason? And we're going to try to understand that here. So let's go back to this example. What I want to emphasize here, and this is the crucial insight of the noisy channel theory as applicable to the present case, is that the contexts that we're seeing in these cases are more common in German than in English. And the reason for that is that German has verb final sentence structure. German often has verbs coming at the end of the sentence, whereas English doesn't. English is verb medial. So there are a lot of cases where there's material that sort of intervenes on one side and the other, and there's material embedded in between a subject and a verb in German, much more often than there is in English. And so there's a basic intuition that we might be able to leverage that contextual distinction to try to explain why this forgetting effect emerges. So for example, an example of this is that in English, for example, relative clauses are verb medial when they're subject extracted. So we have the maid that cleaned the apartment, but they're verb final only when the object is extracted, the apartment that the maid cleaned. So 80% of, roughly speaking, of relative clauses in, say, written English with full noun phrases in the relative clause are subject extracted, only about 20% are object extracted. So most of these contexts are verb medial, not verb final. In German, relative clauses are always verb final. So we have 100% verb finality. And so, well, if you just sort of do a phrase by phrase match to the sequential statistics of 1 and 2, you're going to see, of course, that 1 and 2 are much rarer kinds of phrase by phrase configurations in English than in German. So this leads to a possible noisy context account of structural forgetting. And to do this, we're actually going to integrate noisy context, noisy channel processing with surprisal, which we've used to great effect before. So the idea here is that structural forgetting would mean that the ungrammatical sentence with 2 verbs is easier to process than the grammatical sentence with 3 verbs. That's the signature that we're going to be interested in. That's going to be a structural cost inequality of C as a cost function. And we're going to operationalize that. We're going to schematize this in terms of part of speech sequences. So ignoring the determiners for a moment, we have like noun, that noun, that noun, verb, verb, which has a missing verb, should be less costly than noun, that noun, that noun, verb, verb, verb. That should be more costly. That, if we have that cost inequality, that will give us a structural forgetting effect. So that is that the cost of 2 verbs in this 3 noun context should be lower than the cost of 3 verbs. And the intuition that we want here is we're going to focus on the distinction between which is more surprising. What is the surprisal difference between getting a verb, a third verb after the first 2 verbs in this context, versus getting the end of the sentence, which we'll denote as a hashtag. And we're going to leverage the noisy channel intuition that maybe comprehenders are not representing the context perfectly well, that it's noise or there's some kind of loss of the representation. And that is going to be taking into account noisy channel inference. So once again, on the noisy channel theory, there's a likelihood function. So there's a reconciliation of context representation between likelihood and prior. The likelihood is going to be that there's some possibility, so there's going to be some stochastic process by which the true context, that true part of part of speech sequence, is going to be distorted in some way. But there's also a prior, so there's a prior distribution on how likely each possible context is. And we're going to marginalize over the possible context given a noise context. And then that that set of possible context given the noise context is going to then predict the next word of the verb. Now, the crucial point here is that the prior probability on the actual context is going to be higher for German. And so German is going to be more likely to give us the right prediction that there should be a third verb. And so the idea here is that, well, this is the right context, but in a case like English, we might have the verb go missing. We might have represented, in this case, you see that we reconstructed a context that's missing a noun, that combination. And so if we reconstruct that kind of context, then we're going to wind up with a prediction of the final word. And so the idea here that we developed is that this should work for toy grammars of English and German of the following type. This is just a simple demonstration. To scale up, we'd need a more complex, computationally intensive grammar, or we could think of this as a motivating example of why recurrent neural network models get the patterns that differ cross-linguistically the way that they do. So we're going to have several types of action here. Subject sentences, of course, are going to be noun phrases with verbs. They're going to be intransitive for this purpose. Noun phrases might or might not be modified by relative clauses or prepositional phrases. Prepositional phrases, of course, are preposition noun phrases, but relative clause might be verb final or it might be verb medial. With probability S, it's verb medial. With probability 1 minus S, it's verb final. And so the crucial difference here is going to be that because German is always verb final relative clauses, but English is usually not, that probability of verb finality is going to differ across the two languages. So we just take all the parameters of this model and set them to be the same, except for this probability that a relative clause will be verb final or verb medial, which is different between the two languages. And it turns out that we find that given this simple characterization, we find surprisal differences matching the verb forgetting effect. So if we look at the surprisal difference that we've used before in previous studies of the ungrammatical versus grammatical versions of this, we find that it favors, negative versions are ones that favor the ungrammatical. So the ungrammatical continuation is less surprising. That is, ending a sentence without a third verb is less surprising. Whereas in German, it's the opposite pattern. Ending a sentence without the right verb, without a third verb, is more surprising. Now, that's just for, and then here is, for example, in Besicht et al., 2010, this is the processing pattern on that final verb in eye tracking or self-paced reading. Now, that was only for one setting of the model's parameters. But it turns out that this is a fairly robust pattern. So remember that we have 3 free parameters in this model: the modifier probability, the probability of the English relative clause being verb final. Excuse me, that should be verb medial. The probability of the English relative clause being verb medial, which is variable for English, but is always in German verb relative clauses are always verb final, and the probability of a context token being deleted. That's the noise parameter. And the green region for each of these panels is the region in which you get the English-German-like pattern. The English-German-like pattern is that for English, the ungrammatical continuation is less surprising. For German, the grammatical continuation is less surprising. The blue and red regions are correspondingly where basically in both languages, one is more surprising than the other. The reverse pattern is actually never attested, where in English things are more, the ungrammatical continuation is more surprising, and in German the ungrammatical continuation is less surprising. That pattern never occurs for any of the model settings. So to summarize, our noisy channel surprisal, noisy context surprisal account of structural forgetting is that the probability that context is remembered depends on its prior probability. And you can think of this account as being an explanation for empirical signatures of what we see in recurrent neural networks. And something to notice is that basically a recurrent neural network model is always having to transport the representation of context through this uniform representational space. And so some information is going to be likely to get lost because with finite precision in a compact representational space, we're not going to be able to perfectly represent all context. And since and rare contextual configurations are going to be ones that models have poor experience with, and going to be ones that are going to be unlikely to be represented well. And so in English, you're going to be less likely to be able to correctly predict what the context-free grammar characterization would predict. Because in English, that kind of contextual structural configuration is rare, whereas in German, it's a more common kind of structural configuration. So that's the account. And this model, unlike a recurrent neural network model, has an explicit grammar representation, its competence. But the noisy channel theory says, I can't apply that explicit representation perfectly correctly. And that is a performance component. So like these Bayesian models that we've seen in many settings, we have a competence characterization and a performance characterization, and there's some give between the two. And the give between the two has explanatory power in understanding human sentence processing behavior. This also, we see that this is the first example of where we can see a sort of theoretical linkage between the recurrent neural network models, or more generally the deep learning approaches, where we have a continuous vector representation of context, but we don't necessarily have an easily explicable characterization of why the continuous vector representation will behave the way it does. And the idea here is that the noisy context account might be able to serve as a theoretical bridge between the two, between the explicit grammar representation approach and the deep learning approach. Of course, this is only an evocative idea at this point, and it's a first sort of case study. But hopefully, this idea might be much more broadly applicable going forward.